The shortest distance between any 2 points is, of course, a straight line. But when we want to find the distance from a point to a line, obviously there's lots of different distances you can have depending on which direction that you want. But we want the shortest distance. And the shortest distance will always be the one at right angles, or what we call the perpendicular distance. This is where this formula comes in handy when we want to find that shortest distance from a point to a line. There's our point, call it x1, y1, and there's our line. Now, to make use of this formula, we put the line in general form. Okay? And we just want to find that perpendicular distance d. And there it is in all its glory. It basically is the equation of the line in general form, but we substitute in the points, x1, y1, and on the bottom is Pythagoras' theorem. Square root of a squared plus b squared. So they're the coefficient of the x and the y. We're going to find the equation of a circle with a tangent 3x minus 4y minus 12 equals 0, centre 1 to 4. You might think, well, hang on, how's this relate? But if you remember from your circle geometry, the radius is always perpendicular to the tangent. So if we find that perpendicular distance, that will tell us the radius of the circle. So, right, so there's our circle. Centre's 1, 4. There's our tangent. Sub it in. So we've got the general form on top, but I've subbed in the point 1, 4. And on the bottom, the square root of those coefficients, so 3 and 4. And we get 25 on root 5, which cancels nicely to give us 5 units. Well, that's the radius. The equation, of course, then becomes x minus the x value of the centre squared, y minus the y value of the centre squared equals the radius squared. The reason we have absolute values, sometimes it'll give you negative, sometimes it'll give you positive. So actually, it can be a useful way of finding out whether points are the same side of the line or on different sides. Because remember, if I was to say, shade in the inequality where it's always greater than 0, you would shade on that side of the line. So clearly, every number that we substitute there would give me a positive answer, whereas on the other side, it would give me a negative answer. So what I'm getting at is if you substitute into the general form 2 points, one turns out to be positive, one turns out to be negative, they must be on opposite sides of the line. Whereas if they're both negative or they're both positive, they must be on the same side of the line. That might come in useful for some questions, who knows?